Hello everyone, I am Shubham Keshri and today is the lecture on sets. This is lecture 2. So we'll cover equal sets, what are subsets, the power sets and the universal sets. So first we'll discuss what is equal set. So in the previous lecture we have discussed what are sets. So here equal sets means if the elements of A, each and every element of A is also an element of B, as well as all the elements of B are elements of A, then the sets are equal. You can understand this with an example. So we have here A is equals to this set and B is equals to this set. So we have to check if each element of A is a element of B and each element of B has to be an element of A. So 4 is here, it is here in B. 6 is here, it is here in B. 8 is here, it is here in B. 10 is here, it is here in B, and 12 is here, it is here in B. Similarly, for each element in B, we have to check if it is there in A. So 10 is here, it is here in A, and so on. So if you check, all the elements of A are there in B, and all the elements of B are there in A. So we can say A and B are equal sets. So this is the notation used to denote when the two sets are equal. We can also say that A and B are equal if they have exactly the same elements. So all the elements of A must be an element of B and all the elements of B must be an element of A. Now if a set A and B are not equal, they are sets they are called as unequal sets and it is denoted by A not equal to B. Now here is other examples of equal sets. So I have a set A which is equals to January, February, March, and a set B which is February, March, and January. So each element of A is in B. So we have January in B, February in B, and March in B. Similarly, February is in A, March is in A, and January is in A. So here also A is equals to B. In the third example, we have to see what is A and what is B. So A here is written in the set builder form. First, we have to write A in the rooster form to understand it better. So it is saying X such that X is the set of all natural numbers less than 5. So what are the natural numbers less than 5? 1, 2, 3, 4, 5 will not be there. And 0 will also not be there because 0 is not a natural number. So this is the set A. And here we have a set B, which is 2, 2, 4, 2, 1, 3, 4, 1. So if you remember, in our previous lecture, we have discussed that it doesn't matter if the elements of a set are repeated. So here, some of the elements of B are repeated. It doesn't make any difference. So we will see if A and B are equal. So the elements of A are 1. It is there in B, here and here. 2, which is here in B, these three places. 3 is there in B here and 4 is there in B. Similarly, all these elements of B, 2 is there in A, 4 is there in A, 1 is there in A, and 3 is there in A. So A and B are equal sets. Suppose we have a set, this is A, and we have another set B dash, which is 2, 3, 5, 7, and 8. So in this case, all the elements of A are not in B, neither all the elements of B dashed are in A. So A and B dashed are not equal set or unequal sets. So here are some problems of equal sets. We have A as the set of letters in this word and B as the set of letters in this word. So we have to check if all the elements of A is in B and all the elements of B is in A. So we can write A as T, R, I, A, N, G, U, L, A already written, T already written, E and D. Okay. And we'll write B as A, D, U, L, T, E, R, A already written, T already written, I, N, G. Now we'll check if all the elements are there in both. So T is here, E is here, R is here, R is here, I, A, N, N, G, G, U, L, E, E, D. So there is no extra element in A, neither there is an extra element in B. So A is equal to B. So these two sets are equal to one another. Now we have two sets here, A and B. A is an so the elements of A are a natural numbers and x square is less than 20. So what are the natural numbers with x square less than 20? It will be 1. So A will be 1. So I am writing A in the rooster form. 2, 3, 4. 5 will not be there. So we have 1, 2, 3, and 4. Why 5 will not be there? If we take x as 5, so x square is 25, which is greater than 20. So 5 will not be there. And why we are not going to 0 and minus negative numbers? Because x is natural numbers. So what is B here? B will write it as B are all the real numbers, and this is the equation it should follow. So what is the equation it should follow? It is x square plus 8x plus 16 equals to 0. If you factorize, it will be x square plus 2x plus 4x plus 16 equals to 0. X plus 2 plus 4, x plus 2 equals to 0, or x plus 2 into x plus 4 equals to 0. So either x is minus 2 or x is minus 4. So B, so from this equation, it is coming to these two numbers. And we have to also see if they are real numbers. Yes, minus 2 and minus 4 are real numbers. So B will be minus 2 comma minus 4. Now we have to check if the elements of A are there in B and elements of B are there in A. So it is not the case. So minus 2 is not here, minus 4 is not here. Similarly, 1 is not here, 2 is not here, 3 is not here, 4 is not here. So A is not equals to B. In this example, A is all the natural numbers which satisfies this equation. So this equation will be satisfied by x minus 24 is equals to 18. X will be equals to 42. So x will have only one element, which is 42. And B is such that it is real numbers and x square is equals to 36. So if x square is equals to 36, x can either be equals to plus 6 or minus 6. Now we have to see if this plus 6 and minus 6 are real numbers. Yes, plus 6 and minus 6 are real numbers. So B will have two elements, minus 6 and plus 6. Now A has one element and B has two elements, and all the elements are not same in both the sets. So here also A is not equals to B. So in these two slides, we have seen what are equal sets. So again, I'll revise. Two sets A and B are said to be equal if they have exactly the same elements. So the elements of A should be exactly the same as the elements of B. Then only we'll say that A and B are equal sets. Now we'll come to the topic of subsets. This is a very important topic to understand. What is a subset? We'll say a set A is said to be a subset of set B if every element of A is also an element of B. What does this mean? It means that the elements of A must be an element of B, every element of A. So this will be clear with an example. First, we'll see how we denote it. So we denote A as a subset of B. So this is how we denote it. This represents a subset of. So here A is a subset of B. Okay. So this example will clarify what is a subset. So if we have a set A which has element L, Q, and Z, and a set B which is a set of all the letters in English alphabet. So B will be, you can write it here, B will be A, B, C, and so on till Z, right? Now we have to check that if all the elements of A are there in B or not. So A has L, yes, L will be there in this set. A has Q, yes, Q will be there in the set B, and A has Z, yes, Z will also be there in the set B. So A, all the elements of A all three elements of A are there in the set B. Therefore, A will be a subset of B, right? A has only three elements and all these elements will be there in the set B. So we can say A is a subset of B. The second example, A is the set of all prime numbers, set of all prime numbers, and B is the set of all integers. So if we write set of prime numbers, we can write it as 2, 3, 5, then 7, 11, 13, and so on. And what are all the integers? The integers will be minus dot minus 2, minus 1, 0, 1, 2, and dot. So you can see these elements of A, 2, 3, 5, 7, 11, 13, and so on will be there in the set B, because set B contains all the integers. Therefore, we can say here in this example, A is a subset of B, right? Because all the prime numbers are actually integers, right? All prime numbers are integers. Therefore, the set A is a subset of B in this example. Now we have another set A, which is, sorry, here we have not defined the set A. We are saying the A is a set which is all the rivers in India, and B is a set which all the rivers in the world. So if you see clearly, all the rivers which of the world will have the rivers in India, right? So the rivers which are in India will be a river in the world, right? Therefore, A is a subset of B. All the elements of A, which are the rivers in India, is an element of B, which is a river in the world, right? So A is a subset of B. I hope you understand this example. This is a very good example. I'll repeat it again maybe. So A is a set of all the rivers in India and B is a set of all the rivers in the world. So if we have taken a river like Ganga, which is in India, it will also be in the set B, right? Because Ganga is also a river in the world. So we have A as a subset of B, right? So the fourth example, it says that A is the set of factors of 12. So what are the factors of 12? A is a factor of 12. So it will be 1, 2, 3, 4, 6, and 12, right? And B is the set which is all the prime factors of 12. So if we write only the prime factors of 12, it will be 2 and 3, right? And no other factors will be a prime factor of 12. Now you see all the elements of B is in A. So 2 is there in A, 3 is there in A, here 3 is there in A, and 2 is there in A. So in this case, B is a subset of A, right? So all the elements of B, 2 is there in A and 3 is there in A. So all the elements of B are in the set A. So B is a subset of A. How we define it? So if A belongs to A, capital A, which implies A belongs to B, so we will say A is a subset of B. So this says implies, right? So if A is a subset of B, if this holds, I have written it not, I have not written it very clearly. What this line says is, if A is a subset of B, if this holds, then what will be the case? If A is an element of capital A, the set A, then A will be the element of B, right? So if this holds, then this condition must satisfy. So if A is a subset of B, the elements of A must be there in B. So this line I can repeat and say A belongs to capital A implies that A belongs to capital B, where capital A and capital B are sets A and set B, right? Now there are a few things to note. If A and B are equal sets, so we have defined what equal set is in the first slide. A is equals to B, we denote it like this. Then this thing must hold. So this says if and only if and only if, right? So it says that if A is equals to B, if and only if A is a subset of B and B is a subset of A. So what does this mean? It means that we can take two example, right? So if we have 1, 2, and 3, and B is equals to also 1, 2, and 3. In this case, A is equals to B. Now, A will be a subset of B because all the elements of A are there in B. Similarly, all the elements of B is also in the set A. So A is a subset of B as well as B is a subset of A. Therefore, A will be equal to B. This implies both sides. So if this holds, this will hold. If this holds, this will hold. Okay. Now, the second point to note is every set A is a subset of itself. So if we have this set A, then A will be a subset of itself A because all the elements which are in A will be an element of that set itself, right? So A is a subset of A. Understand it very clearly. So we have a set A and we take one element of that set A. If that element belongs to A, it also belongs to that same set A. So this says that every set is a subset of itself. One more thing to note, which is very important, is if a set is empty, suppose I have a set X which is empty. Now it has no element, right? It has no element. So all the set which has some element, it also has no element. So what does this mean? That it says that empty set phi is a subset of every set. So this we don't have any element to compare it with, right? So if a set is empty, then it will be subset of every other set. So if we have a set like this A or a set like this B, an empty set will be a subset of this. So we can say this empty set phi or X here in this case is a subset of A. X is a subset of B. An empty set is a subset of every set. This is very important, huh? An empty set is a subset of every set as it has no element. So we cannot compare it with any element in that set. And we thus say that an empty set is a subset of every other set. Now we'll define what is a proper subset. So we say that A is a subset of B, but A is not equals to B. So we can take an example. A is equals to 1, 2, 3, 4, and B is equals to 1, 2, 3, 4, dot, dot, dot till 15, right? So A is a subset of B, right? All the elements of A are there in B, but A is not equals to B. Clearly, you can see that there are more elements in B than A. If these two conditions hold, that is, if A is a subset of B and A is not equals to B, then A is a proper subset of B. So this is the definition of a proper subset. Similarly, we have a definition on superset. So in this case only, since B has extra element and A is a proper subset of B, we can say that B is a super subset of A. Okay. We have few more examples here. So it is a similar example which I gave. A is equals to 1, 2, 3, 4, 5 and B is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. So here A is a proper subset of B and B is a superset of A. Similarly, I have given here example that A is the set of factors of 12. So what is the set A? Factors of 12 will be 1, 2, 3, 4, 6 and 12. Yes. And factor of 24 will be 1, 2, 3, 4, 6, 8, 12 and 24, right? I'm correct. Yes, I'm correct. So you can see all the elements of A 1, 2, 3, 4, 6, 12 are there. 1, 2, 3, 4, 6, 12. All the elements of A are there in B, but A and B are not equal. So A is a proper subset of B and B is a superset of A. Okay. So here are a few problems on subsets. Which of the following has a set which is a subset of the other? So here we have A and here we have B. So A has A, E, I, O, U and B has A, B, C, D, E, F. So you can see A is there in B, E is there in B, but I, O and U is not there in B. So A is not a subset of B. Now we have to check the other way. This A is there in A, B is not there in A. So neither A, so A is not a subset of B and B is not a subset of A. So this is the way of writing not a subset this way, not a subset. So A is not a subset of B and B is also not a subset of A. So in this example, we have A is equals to the set 1, 3 and 5 and B is the set of all natural numbers less than 10. So what is the set of natural numbers? It is 1, 2, 3 and so on till 10, sorry, 10, right? So if you see that 1 is there in B, 3 is there in B and similarly 5 will also be there in B. So A is a subset of B. Moreover, you can see that A is a proper subset of B because all the elements of A are there in B and B has some extra elements. So A is not equals to B. So these two conditions, if this and this condition holds, then we can say A is a proper subset of B and B is a superset of A, right? So we are moving into the next slide. Now we have here what are subsets of set of real numbers. So in previous lecture, we discussed some of the set of numbers or mathematics. So we have written it here. So what is n? N is the set of all natural numbers. In previous lecture, we have discussed this. Z, Z is the set of all integers. Q, Q is the set of all rational numbers. R is the set of real numbers. T is the set of irrational numbers. What is a rational number and irrational number? I'll define it one more time here. So a rational number can be written in a fraction of p by q, where p and q are integers, right? So this is a rational number where we can write in a fraction form p by q, where p and q are integers. And all the real numbers, all real numbers that is not q. So we can write t as like this, x such that x belongs to real number and x doesn't belong to q. So what does this mean? So x are all the real numbers as well as it is not rational number. So then it will be irrational numbers. So these are few sets here. So in natural numbers starts with 1, 2 and so on till infinity, right? 1, 2, 3 and so infinity. Integers, I have said it starts from minus infinity to minus 2, minus 1, 0, 1, 2, dot, dot, dot till infinity, right? Rational numbers I have written all the set of all the numbers which can be written like this, right? This is not the correct way to write it. It will be like x such that x equals to p by q, where p and q belongs to the set I integers. This is the correct way of writing it, right? And the set of all real numbers, it is very simple to write x such that x belongs to, okay, we are using r now, so we cannot write here r. So this will not be correct because we are defining r. So we can say that x such that x, or we can say minus infinity less x less infinity. So this represent all the numbers which are there in R, or we can also write it as minus infinity to plus infinity. Sorry, this bracket. How we are writing this will come to the next topic of in this lecture itself. So we'll define how we are writing this. Now we have to notice few things. When we see natural numbers, so this is the set of all natural numbers. When we come to natural numbers, you see these numbers are there in the set this. So this is the set integer. Sorry, Z. I'm writing Z. It can also be written as I. So it can also be written as the set I. I is also an integer number denoted by integer numbers. So all the numbers which are there in the set natural numbers n are there in the set integers. So we are writing n is a subset of Z. Now this Z are, what is Z? Z is the set of all integers. So these are a subset. This set is a subset of the set Q. Why? Because each number minus 2 or minus 1 or any other number can be written as minus 2 by 1 minus 1 by 1 or any other number. Suppose we have 1243. It can also be written as 1243 by 1. So these are all the numbers which are there in the set Z, integers. So these numbers are also rational numbers. So Z is a subset of Q. All the numbers which are there in the set Z or integer is a subset of Q. Now if we see this Q contains all numbers which is can written by P by Q, where P and Q belongs to integer, right? Now this all the numbers which are there in this set is a real number, because real number is all the numbers which are there in which we can think of from minus infinity to plus infinity. So Q is a subset of R. Now here is some interesting thing to note. So since N is a subset of Z and Z is a subset of Q, N will be a subset of Q, or N will be a subset of R, right? Because N is a subset of Z and Z is a subset of Q and Q is a subset of R. So N will be a subset of R. All the numbers which are there in N will be there in R, but the reverse will not be a case. So N is a subset of R, right? You can check, right? 1, 2, 3, 4 and so on. These all numbers will be there in the set real numbers. So this also holds. Similarly, this set of irrational numbers will also be there in real numbers. So T will be a subset of R, right? So moving on to the next slide. So we will see how we can write in the interval form. So in this previous slide, I have written this in the interval form. So what does this mean? We'll see in the next slide. So what is R? R is the set of R is the set of real numbers. You can write the real numbers in the real line like this, from minus infinity to plus infinity, right? So this is the real line. You can write some of the numbers here, 0, 1, 2. You can write any number here. You can write 2.5 or suppose 100.23757, something like that. All numbers will be there in this line from minus infinity to plus infinity. Now suppose we take two numbers A and B, or two elements of the set R which belongs to the set R. So suppose I have an element A and element B. What is the condition? The condition is A should be less than B. So I have drawn it correctly, A and B. So what is open interval? So two terms are very important. What is an open interval and what is a closed interval? So for open interval, it means that the set of all those y's which is less than A and greater than B. So this should hold. Now you have to see one very important thing here. Y is greater than A. It is not greater than equals to, it is greater than A. And Y is less than B. It is not less than equals to. So it will contain all the numbers in between A and B, excluding A and B. A and B will not be the part of this set, right? This set. So it will be here, this A and B. All the numbers in between A and B will be there in this set, right? And it is denoted by this. It is normal bracket A, comma B. Okay. Now you will understand why this is important when we discuss closed interval. What is a closed interval? The interval that contains the endpoints. So here A and B were not included in that set. So if we have a set Y which satisfies this equation A, where Y is greater than equals to A and less than equals to B. So we have equals to. So A and B are included in this set. So this will be like this. And it is denoted by this box bracket A, comma B. So this is known as the closed interval, right? So A and B. So all the numbers in between A and B, both A and B included, is called the closed interval. So we write closed interval with box bracket and open interval with normal bracket, right? We can have mixed things also. So here I have given an example. So if we write like this, what does this mean? It says that all the numbers in between A and B, but A is included, right? Closed interval is there here, and B is not included. So here I have written it for clarity. X is greater than equals to A. So A is included, and X is greater than, sorry, less than B. B is not included. So we have written it like this: A comma B not included, right? So this is the closed interval, this is the open interval. So in number line, this A and B, so A will be included. Suppose A is 5, so 5 will be there, and B is suppose 7, so 7 will not be included. It will be little less than 7. It will not exactly be equals to 7, I mean. So this is just opposite of that. So A is not included and B is included. A combination of both the open interval and closed interval. So this is an interval, and these intervals are actually sets. So this is a way of representing an interval in the form of set. So this is a set, this is a set, and all these are sets. What numbers are included in this set? So suppose I am talking about this. So all the numbers in between A and B, not including A and B. So this will be the set, right? So if we go one slide for behind and see, I have written this thing, right? It says that R is actually equals to minus infinity to infinity. So I'm not including infinity and minus infinity because it is not actually included in the real number. So all the numbers in between minus infinity and plus infinity are there in real numbers, excluding minus infinity and infinity, right? So this is a representation of a set in interval form, right? It is very important. In mathematics, when you learn other chapters, you will come across this term or this expression of set. So this is all about interval form. So in the next slide, I have written visualization in real numbers, which I have already done. I'll do it one more time. It's not an issue. So suppose I have a number line from minus infinity to plus infinity, and I have two numbers A and B, and we have an open interval in A comma B. So generally what we do is in open interval, we'll draw a hollow circle. Okay. And we'll say this is the set in between A and B. What does the hollow circle mean? It means that A will not be included. So the number 8 can be 7, 14 or something like that. Anything will be there. Open interval. Both are open interval. Okay. So this number 7 will not be there. Just above that number 7 will be included. So all the number in between 7 and 14, excluding this number 7 and 14, right? So if we have closed interval, how to denote it? So suppose we have the same thing, 7, 14, open interval in 7 and closed interval in 14. So in this case, here will be a hollow circle, but here will be a darkened circle, or it will not be hollow. It will be a darkened circle. So this is the way to represent intervals. So here will be hollow means, so hollow represents open interval, and this is closed interval. So some examples are here. So these examples are of subsets. So what is A? A is a set from minus 8 to 2, minus 8 not included and 2 included. So if we draw a number line, and it will be helpful for us to understand. Okay. So minus 8 is here and 2 is here. So this is A. So open interval in minus 8 till 2. 2 is included. So close interval in 2. This is the set A, right? What is set B? Set B is, let us draw another line. Set B is 8 is included. So we'll draw a darkened circle here, and 8 is included till 9. So 9 is not included. A hollow circle here. We'll write it like this, right? This is B. Now you see all the elements in A is a part of B, right? Is an element of B. So we can say A is a subset of B. You can see, right? Similarly, here minus 2 to 6, where 2 is included and 6 is not included, and B is minus 4 to 9, where minus 4 is not included and 9 is included. You can clearly see that A is a subset of B. Now, suppose I give a very interesting example. Suppose we have this from minus 8 to 2, where minus 8 is included and 2 is not included, and B is from minus 8 to 9, where minus 8 is not included and 9 is, we can write it anything, 9 is included. So you see, in this case, 8 is minus 8 is included, and here minus 8 is not included. So the element 8, which is an element of A, is not there in B. A minus 8, sorry. Minus 8 is an element of A, but minus 8 is not an element of B. Therefore, A is not a subset of B. Okay. Because 8 minus 8 is included in A, and here minus 8 is not included in B. So A is not a subset of B in this case. So some important things to note in this part. So if we say non-negative real numbers, when we are saying non-negative real numbers, 0 will be included because 0 is neither negative nor positive. So all the real numbers which are not negative, 0 is not negative and positive numbers are not negative. So we'll have a set or an interval from 0 to infinity where 0 is included. So this is a very important term to remember, non-negative real numbers. The second is negative real numbers. When we say negative real numbers, 0 will not be included because 0 is neither negative nor positive. So we'll have from minus infinity to 0 where 0 is not included. And always remember, infinity and minus infinity will always have an open interval. You cannot have a closed interval in minus infinity and plus infinity. Okay. The set of real numbers, I have told you that it is noted as an open interval from minus infinity to plus infinity. Now this point is very important. The length of any interval A, B, where one of them is included and one of them is not included, or you can say one is open interval, one is closed interval, in any form, the length will always be equals to minus A, B minus. Okay. You include A or not, you include B or not, it doesn't matter. The length of that interval will always be equals to B minus A. In this example, you can see. So if this is B and this is A, this will be the length of the interval. It doesn't matter if you include A or B or not. It will always be equals to B minus A. Okay. So here we have one problem. So what is the problem? It is saying that we have some sets here. You have to write it in the set builder form. It is very easy to write these sets in set builder form. You can say X such that X belongs to real numbers. Okay. You can say real numbers or you can say integers. No, you have to say real numbers because this is an interval form, right? It is a real number such that it is a real number and like this, X is greater than minus 3 and less than 0. Okay. In this example, you have to write X such that X belongs to real numbers, and if you write 6, 6 is included in X and also 12. So X is greater than equals to 6 and less than equals to 12. So this is the set builder form for this expression or this set, and this is the set builder form for this set. Okay. Now the concept of power set. What is the power set? Power set. So a collection of all the sets of a collection of all subset of the set A is called a power set. So what does this mean? It says that if we have a set A and we can write some subset of that set A, right? So here we have a set A. So suppose capital A is the set of element A comma B. So whatever subset we can make of A, all the subset we can make of A will be the power set of A. So what are the subsets of A? So first will be an empty set is a subset of A. Then we'll have only the element A. It is a subset of A. Then we'll have A comma B, which is an subset of A. Then we'll have B, right? So 1, 2, 3, 4. There are 4 subsets of A. I guess there are no other subsets of A, right? So this collection is actually denoted by P of that set. Here, that set is A. And this collection is known as power set. So what is a power set? The power set is the collection of all the subset of a set. Therefore, this is a power set and it is denoted by P of A. If A is the set, any other set is there if B or C is considered. So we'll write P of B or P of C. Now, if A has M elements, right? This N of A denotes the number of elements in A. So if A has M elements, so the number of elements in the power set will be given by this formula 2 to the power M. Okay. So over here, N of A is 2. So 2 to the power 2 is actually equals to 4. So you can see here in this set, N of P of A is actually equals to 4, right? So if an set A or any other set has a M number of elements in it, M. So the number of elements in the power set will be given as 2 to the power M. So if a set has 3 elements, then the power set will have 2 to the power 3 number of elements. If a set has 13 elements, then the power set will have 2 to the power 13 elements. How was this coming? It comes from actually permutations and combinations, actually combinations. So I shouldn't describe it here. Um, Actually, it says that if you want to include A or not, there are 2 conditions. You can include A and not. Similarly, if you want to include B or not, and so on. So in each of the element, you have 2 choices. So for each element M, you have 2 choices. So 2 to the power M. You'll more understand this when you study permutations and combinations. Okay. So what is the key takeaway from this slide? What is a power set is one takeaway. So the collection of all subset of a set is called the power set of A. The second key takeaway from this slide is the number of elements of a power set is given by 2 to the power M, where M is the number of elements in that set A, right? M is the number of elements in the set A. So the number of elements in the power set of A will be given by 2 to the power M. So here are few examples which we have to do. So first is a set 0, 1 and 2 with 3 elements. So if the set has 3 elements, what will be the number of elements in the power set? It will be 2 to the power 3, which is 8. So we'll have 8 elements in the power set. So I'm writing the subsets, the power set of this set. So first we'll write the empty set. Obviously empty set will be a subset of the power set or element of the power set. First will be 0, then we'll write 1, then we'll have 2, then we'll have 0 comma 1, then 0 comma 2, then 1 comma 2, then 0 comma 1 comma 2. How many we have written? 1 2 3 4 5 6 7 8. All we have written. Yes. So it will have 8 elements and these are the elements of the power set. So if this is X, the set X, so P of X will be given by this set. What is this? This is the power set of the set X. Now if we have a set as the empty set phi, so phi, if A is empty, the number of elements of A is actually 0. N of A is 0. So what will be the number of elements in the power set of A? N of P of A, it will be 2 to the power 0, which is 1. So what will be that element? P of A will have only one element, which is 5. Okay, will have one element. What is that element? It is the null set. Now, if A is this set which has only one element A, so number of elements in the power set will be 2 to the power 1, which is 2. So what is that power set? It will be 5 and A. Okay, two elements will be there in that power set. So these are some of the problems on power sets. Oh, okay, we have one more example. So how many elements does P of A have if A is 5? Oh, we have done this example here. So it is same. So if A is 5, the elements, the number of elements in the power set will be 1, right? We have shown it here. So this will be 1. The number of elements in the power set where a set is empty is 1. Okay. The last concept here is of universal set. So what is universal set? The set that includes all possible elements under consideration is the universal set. So if we take an example of English alphabet and we have a set A, suppose, which is all the vowels, so A, E, I, O, U, and B is the set of consonants, so B, comma, C, comma, D, comma, F, comma, dot, dot, dot till Z, right? These are the consonants. So in this case, we can think of a set or which is the universal set. What will be the universal set which contains all the elements of these kind? It will actually be the set of all English alphabets, right? A, comma, B, comma, C, comma, D, comma, E, comma, dot, dot, dot till Z. So universal set in this case will be the set of all the letters in English alphabet. And you can see that I have denoted the universal set as U, which is actually the case. So U is the letter which is used to denote the universal set. Okay, and actually this universal set sets the boundary of the problem or the scenario, whichever whatever is the maximum or all the elements which can be there in this context of set is included in the set of universal set. So universal set can be finite or infinite. So in this example, we have seen that the universal set is finite. It has 26 elements, A to Z, right? The number of elements here in universal set will be 26. One example of universal set where the set is finite is real numbers. So if we have a set A which is equals to 1, 2, 3, 4, and 5, suppose. So we can have a universal set as the set of all real numbers. Or in this case, we can also have U as the integer, right? So these are all integers, 1, 2, 3, 4, 5. So universal set can be an integer. So you can see that universal set depends upon the context. So if only A is there, so for this set, the universal set can be just integers or it can be real numbers. It has to have all the elements in the context. So in this case, the universal set is infinite. Any subset of the universal set is a proper subset, right? So if there is a subset of the universal set, it is a proper subset. Otherwise, it will be the universal set itself. So if we have a set which is equals to the universal set, so it will be a universal set. Therefore, any subset of the universal set will be a proper subset. So we'll do some problems for this. So suggest some universal set for the following. So we have a set with right triangles. Now you can see right triangles means a triangle which has a right angle in it, right? So universal set here can be a many sets you can think of. The universal set can be, you can write it like this, set of all triangles, right? Or we can write U as the set of all polygons, because a triangle is a polygon and a right triangle is also a polygon. So here universal set can also be the set of all polygons, or you can also write as the set of all triangles. So it doesn't matter. So you can see that universal set is context dependent. Suppose in this only, in this problem only, we can have a set which is circle. So if another set is there, which is the set of circles or squares or something like that, or circles. Now you see, this will not be a universal set in this case. So if we have two sets, the first set says is the set of all right triangles, and B set of circles. So this universal set will not have the elements of the set B. In that case, this will be the universal set of all polygons, because circle is also a polygon, right triangle is also a polygon. So in that case, the universal set will be the set of all polygons. The second example we have, or the second problem which we have, is in dot 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 minus 2 minus 1 0 1 and 2. So you see, it seems that these are the elements of the set integers, set of integer numbers. So you can have the universal set as the set of all integers, right? Or you can also think of it as the set of all real numbers, right? Both will satisfy, both will be a set whose this set is a subset of. So in that case, you can have a universal set either as the set of all integers or as the set of all real numbers. So these are some of the problems which I had made for you to discuss in this lecture. So what did we discuss in this lecture? We discussed what are equal sets. So what are equal sets? The sets which have exactly the same elements are known as the equal sets. Then we discussed subsets. So in subsets, we discussed how do we denote subsets? What is when a set is known as a subset of other set, right? Then we discussed power sets. So what is power set? The collection of all the subset of a set is known as power set. Okay. And universal set. So it is actually the collection of all possible elements in the sets is known as the universal set. So these are the three topics which we discussed in this lecture, and we did some problems. I hope you understand. I would request you to do some problems on your own in these topics and practice. Until and unless you practice these topics, you will not get used to this solving, used to solving the problems on this chapter. I hope you like my lecture. Thank you for joining.